Hello and welcome to the Titus Timeout podcast. I'm Jenny Civey and today we're going to talk about how sound adds. This is something you need to know if you have two diffusers in the same space, for instance. What are they going to sound like together? I'm going to use a graph from the catalog on this one instead of trying to draw it out. Say you have two sound sources. One source is 80 dB and another source is 74 dB, and we're assuming it's in the same frequency. How do those sound sources add? How loud are they together? Is it 80 dB plus 74 dB or 154 dB? That'd be a really loud world. It'd be like listening to fireworks from 3 feet away. So how does it really add? What you do is you take the difference between the two sound sources, in this case 80 minus 74 is 6 dB, and you go over to this graph. You go up from 6 to the curve, and then over to the correction, in this case 1, and you add that to the highest decibel reading. So 80 plus 1 is 81 dB, and that's a lot better. There are a couple of things I'd like you to notice on this graph. First of all, on the left, you can see that the difference between the two sound sources is 0, then you add 3 dB. This means that two identical diffusers in an office will sound 3 dB louder than the individual diffuser in the office. Also, on the right of the graph, you can see that the difference between the two sounds is more than 10 dB. You basically only hear the louder sound source. One thing to remember is that this is for two sound sources in the same octave band or the same frequency. If you have a whole spectrum of sounds, you would need to do this for each octave band to determine how much louder it would be. So that's how sound adds. Thanks for taking a time out with us.